Hey guys, this is lesson 533, Law of Cosines, and this is actually your last new material for the whole year in geometry. So I'm lucky to be able to give you guys just a little lesson on how we do this thing called Law of Cosines. Mr. Carnes talked to you about Law of Sines yesterday. Today's Law of Cosines. There is a Law of Tangent you can look up, but it's really crazy, and we don't even teach that in any of the levels through pre-calculus. So over here, I've listed the three equations for Law of Cosines. And just like Mr. Carnes said with Law of Sines, don't get overwhelmed by this. This certainly looks crazy. And the fact that there are three really looks crazy. But for any given triangle, you're only going to use one of those three equations, okay? And I want to talk about them for a minute so you know how to decide which one you're going to use, okay? If you look, the beginning is little a, the end is big A. So those two letters always match up. In the middle, there's a b squared and a c squared. There's a b and c here. Now, if you cover up this part, that's just the Pythagorean theorem, okay? So law of cosines, just like law of sines, can be used in any triangle. That's one thing Mr. Carnes talked about yesterday. This is a pretty cool thing because now you're going to be able to find any angle and any side if you know three parts of the triangle. If you look here, it's the same thing. The beginning and the end are the same letter. Lowercase means sides, uppercase means angle, plus we always find cosine of an angle. It doesn't make sense to find cosine of a side, okay? And then in the middle, A and C, A and C. Starts with little c, ends with big C, in the middle, AB, AB. Okay, so I promise you, although this looks really overwhelming, it's not hard, okay? Just a reminder, Mr. Carnes talked about this yesterday. How do we label a triangle? Well, capital letters have to be for the angles, lowercase letters have to be for the side lengths, and it's always opposite, okay? Always opposite. So here, if I'm looking at angle A, the opposite side is the only side that doesn't help form angle A. And if I'm looking at angle B, side B is the only side that doesn't help form angle B. Same thing for angle C. Side C is the only thing that doesn't help form angle C, okay? Now, just a brief review of what we talked about yesterday with Mr. Carnes. The law of sines and law of cosines can be used in any triangle there is. And there's three ways, and Mr. Carnes talked about this yesterday, when you would use the law of sines. So this one is actually ASS. I'm going to spell it backwards like he did. Oops. ASS is a good time to use law of sines. AAS is another good time to use law of sines. And ASA is the third good time to use law of sines. Now, you don't have to have this stuff memorized. For this year especially, we're going to just tell you, use the law of sines to solve this problem. Use the law of cosines to solve that problem. The other thing to remember with law of sines is when you know an angle and a side across from each other, like Mr. Carnes talked about yesterday, that's a good time to use the law of sines, okay? Now here we don't know an angle and a side across from each other, but we can very easily, like Mr. Carnes showed us yesterday, figure out what the third angle is, and now we know an angle and a side across from each other, okay? So today, law of cosines, there's two times when law of cosines is a good thing to use. One is SAS. So if you notice in this picture, I do know an angle, but I don't know the third side, okay? I do know two sides, but I don't know the angles across. When you don't know an angle and a side, and it's not easy to find that third angle, that's when you want to use the law of cosines. The other time when cosines is really good is when you know the three side lengths and you want to find one of the missing angles. We're not going to cover this today or this year. When you guys get to pre-calculus in 2 years, you're going to learn a lot more about this, but we're not going to go into this one today or this year. Okay, so we're going to focus on this side, angle, side. This one is side, side, side. So I'm going to do one example with you, and then I'm going to have you try one on your own. Okay, so here's my example, and you can notice, like I said, this is side, angle, side. The known information are two sides and the included angle. And what we're trying to find is that side length across, or the third side. So, just like Mr. Carnes talked about, I think absolutely this year you guys need to be labeling this stuff. So you can label this ABC anywhere that you want, okay? There's nothing special about where you put your ABC capital letters for the angles, but it's something very special about where you put the lowercase. So again, here's my angle B, so this has to be side B, okay? Here's my angle C, so this one has to be side C. And here up top is my angle A, so the 20 has to be my side A. Now, which of these three things do I want to use? Well, I only know one angle, and that angle that I know is angle B. And this equation here is the only one that has angle B in it, capital B. So that's how I know this is the equation I want to use. Whatever angle I have goes at the very end of my equation, okay? So I'm going to start filling in. I'm going to start B squared equals A squared plus C squared minus 2AC times the cosine of B. Okay, well, what is little b? Little b is x. We don't know that. X squared. Ooh, that's going to be important in a minute. Equals A squared. Okay, well, I labeled A as 20. So 20 squared plus C. C is 14 squared minus 2 times little a is 20, little c is 14, times the cosine of B. Big B, that's an angle. Big B is 60 degrees. Okay, now if you'll notice, I have a bunch of stuff over here, but it's all numbers. Okay, my variable, the thing that's missing, is by itself almost on the left side. So I actually can type all of this into my calculator at once, and that's what I'm going to recommend that you do. When eventually, if you had a missing angle here, I would recommend something slightly different, but we don't have that. We're not going to worry about that this year. You can plug all of this in, okay? Just like for inverse trig, what Mr. Kleinhens did for you last Friday, and law of sines, we're dealing with degrees here. So we better make sure that our calculator is in degree mode. So we're going to go to the mode button and scroll down. And the third one down says radian, and right next to it says degree, and make sure degree is highlighted. If it's not, go ahead and fix that. Okay, then I'm going to quit. And I am just going to type all of this in. So 20 squared plus 14 squared minus 2 times 20 times 14 times the cosine of 60. Okay, and when I hit enter, I get 316. And you might be thinking, well, wait a minute. This side's 14, this side's 20. There's no way that can be 316. And you would be right. Remember, this says x squared. So just like in the Pythagorean theorem, if this is x squared equals 316, I'm just going to take the square root of that answer, and I'm going to get that x is approximately 17.78. Okay, now that looks more reasonable with these numbers that I have. Okay, so that's example number 1. Example number 2, right here. Okay, I want you to pause the video. I want you to try it yourself. And once you're done, you can check answers with me, and I will show you how to do this. All right, so hopefully you paused the video, you tried example 2 on your own. I have labeled A, B, and C, and maybe you labeled it differently than mine, and that's okay. What will end up happening should still be the same result, even if you labeled your triangle a little different than mine. You might have even used a different formula than mine. If you have B here, those would be B's. If you have C here, those would be C's, okay? So in this case, A is X, that's what I don't know. Little b is 7, little c is 6, minus 2 times 7 times 6 times the cosine of, this is always an angle, and the only angle that I'm given is 120 degrees. Again, I'm going to type all this into my calculator at once, being careful to make sure that what I get as an answer is a reasonable answer. Okay, and I'm getting 127, and again, that's equal to x squared. So when I square root that, I'm getting approximately 11.27. Now, just as a quick reminder, the biggest angle, which 120 has to be the biggest angle in the triangle. You can't have anything bigger than that and add up to 180. So the biggest angle in the triangle should be across from the biggest side, always. Okay, so that is a reasonable answer, okay, because this is the biggest side length, okay? I hope this was helpful. If you're confused, please email your teacher, okay? And you guys, thanks for hanging out with us for this last quarter. This is not the way us as teachers wanted to end the school year, but we're really glad that you guys hung in there with us while we were learning different things, kind of trial and error, and we just really appreciate all the work that you've put in for this quarter.